Hi there, and welcome to Inside Quantum, the podcast telling the human stories behind the latest developments in quantum technologies. I'm Dr. Stephen Thompson, and I'll be your host for this episode. In previous episodes, we've talked a lot about quantum technology hardware and software, but we haven't talked much about the broader ecosystem surrounding these technologies. After all, quantum computers are no use unless we have people who understand them and can program them. But how do we go about developing the necessary tools, and how can we inspire and train the quantum workforce of tomorrow? Today's guest works on solving exactly these challenges. It's a pleasure to be joined today by Junye Huang, a quantum developer advocate for IBM Quantum in Madrid. Hi Junye, and thank you so much for joining us here today.
Thank you for inviting me for the podcast. It's a pleasure.
So before we get into the details of just what a quantum developer advocate does and your amazing work in developing quantum games to make quantum computing concepts more accessible, let's first talk a little bit about your journey to this point. And let's start right at the very beginning. What first got you interested in quantum physics?
Yes, I have been always interested in physics in general since it became a subject in secondary school in China. But what really got me interested in quantum physics in particular was that in, I think, around second year of my high school, I went to a bookstore and randomly just stumbled upon in a book that talk about quantum mechanics history. And it's called Das Gott Play Dice. Obviously, it was written in Chinese, but that's the name of the translation. And it was a quote that Albert Einstein, I think, talked to Niels Bohr, saying that quantum mechanics is not true. God shouldn't play dice. And that book is really, really nicely written, and it's written almost like a novel. But it talks about really the overall development of quantum mechanics history from the beginning of Hertz discover electromagnetic wave all the way down to like the Copenhagen interpretation, and also later multiple universe, multiple interpretations. So it's really fascinating because, as I mentioned, it's like a novel, not so much like a history book or a physics textbook. So really captivated my imagination and made me really, really want to study more about quantum physics. So I think that was the moment that really got me interested in quantum physics.
So you started young then, if you were in high school?
Yes, but that wasn't a moment I decided to be really like thinking that could be my career. It was just like really get me into like really interested in this subject.
I see. So when did you decide that you wanted to make a career out of quantum physics?
Yeah, that was a more roller coaster journey. So even though I say that in high school I got interested in quantum physics because of reading that book, I didn't choose physics as an undergraduate degree because I was interested in physics but also in chemistry. And then I guess my high school teachers say that there's a degree called materials engineering that allows you to learn both physics and chemistry, and I think, okay, that sounds really good. So I chose that. But soon after, like second year or third year, that I realized I don't really like materials engineering because, I don't know, the materials research are a bit more like what we say, cooking, that you do a lot of trying this and trying that, and there's a lot of try and error. Mm-hmm. And I wanted to learn something, I wanted to gain a deeper understanding of things and trying to figure out things. And around that time, we have a conference in Singapore. I studied undergraduate in Singapore. And that was for overseas Chinese physicists. And in that conference, I have seen a lot of great developments and heard a lot about stories of physicists contributing to physics. For example, there's one physicist talking about her 30 years of journey of hanging for Higgs boson. And also I heard a lot of big development of like big scientific experiment in China, like we're planning to build big colliders or big detectors for detecting dark matters. So all these things make me really excited. And different from like the book I read, which saw all these historical figures that passed away long ago. These people that I met in the conference, the story I heard are much more real life. And so I felt for the first time that being a physicist might be not just something that you have in a dream or you write in a story when you are primary school. It could be something realistic. So at that moment, I think maybe I can try to be a physicist. But of course, it's because I don't have a very strong physics background. So it's really hard for me to really become a physicist. I try many different things, and it's a very long story, so I'm trying to make a quick summary. So I tried to apply for a theoretical physics PhD, but obviously got rejected because I don't have the background. And then at the end, I got into a experimental physics degree in a lab that's specialized in spintronics in two-dimensional materials, such as graphene. But obviously, I'm still more interested in quantum computing. So I'm trying to figure out the ways that whether I can do some quantum computing research with the limitation of my lab, which is specialized in spintronics. And I got a chance. There was a grant call, and then I talked to my supervisor, and he was very supportive, so I wrote a grant with my supervisor to make, using the two-dimensional materials. And there's something called van der Waals heterostructure, basically stacking different kind of two-dimensional materials like graphene, black phosphorus, or other kind of two-dimensional materials. And then there could be emergent properties gaining from this. And using this, and of course I read a lot of paper and theory to try to see that it could make sense to make something for topological quantum computation, or maybe you have heard in some article, Majorana fermions or Majorana zero mode. So that was the proposal, and we got lucky and we got the grant, and that was 3 million Singapore dollars, which is a substantial amount of money.
Yeah.
So I got really excited. This is like a dream of me, like to make up something in the lab, but it didn't. We got a grant, and then we started doing experiment, and it became really difficult. There's many reasons, because my lab doesn't have the expertise to do this extremely low temperature. We have the facility to do. We have a dilution refrigerator and measure things in millikelvin, but our lab doesn't do those very sensitive measurements. So I have to learn a lot of things that maybe are taken if you go to a lab that already have experience of doing very low temperature measurements. So things like making a well-known noise amplifier to measure where like qubit signal, sending waveform is very difficult. It took me a few months to figure out, because these are the things that normally don't mention in papers. To say, well, how to make these small little things. You have to dig in the PhD thesis. So so that didn't go well, and I got very depressed because there's like the experiment doesn't really go on. And also the overall lab environment was not going very well. There was very little research output in the lab. So I suddenly feel there's like little future for me to become a physicist, because if you don't have good research output during a PhD, it'll be harder for you to get a decent postdoc, and it'll be harder to get a permanent position somewhere. So it become like really, really hard, and I see like there's little hope. And then at that time, just by chance, someone from IBM came to National University of Singapore, where I was doing PhD, and she mentioned about there's something called Qiskit. And there's a Qiskit camp, which is like a hackathon that is going to happen in New York. Around the time that I was anyway going to APS March meeting, American Physics Society March meeting. So I was thinking, okay, this is something so cool, and anyway, I already going to go there. I have to take tickets. I'm going to get paid by my university to go there. So I asked her to give me an invitation, and I got it. And then I went to Qiskit camp. And in the Qiskit camp, I make a quantum game called Q-Pong, or quantum version of the Pong game. And that was actually a very fun experience, 24 hours that we make the game happen. But it didn't go anywhere in the hackathon, like we didn't win any award. But after that, this is really a long story. After that, I continued working with my mentor in the hackathon. I polished the game, and that was actually showcased in the Boston Museum of Science for a science fair. And then I continued working with another team that we rewrote the Q-Pong using the Unity game engine, which is a real game engine. The original Q-Pong was written in Pygame, which is not really someone that we use to a production game. It's just for people learning programming. And so we make it into using Unity game engine to make a real game. And that is actually also running on a physical mini arcade machine, Quantum Arcade. And that was what actually tour around Europe, including a EU quantum flagship program, educational event in Finland. And that just made me feel like the research I've been doing for 2-3 years, and things are failing, and nobody really cares what I do, because until the moment you publish a paper, nobody knows what you are doing. And then on the other hand, I'm just making this small little game. It's a pretty trivial thing, like you don't need to spend so much effort. But it seems like it have an impact. People care about these things I do. So that's the moment I start thinking, maybe there's a different path in career beyond just becoming a researcher. Maybe I can do something for community, for education. Mm-hmm. And then a bit after that, Q-Pong was actually highlighted in a very popular Qiskit YouTube series called Coding with Qiskit. And there was the first ever episode of Coding with Qiskit was using Q-Pong as the highlight. And someone from CERN saw that, and CERN was going to organize a quantum hackathon. And the organizer invited me to fly to CERN to attend that.
Wow.
And as part of the hackathon, I was also have the opportunity to see the Large Hadron Collider, mm-hmm. which is just a dream for someone that wanted to be a physicist. And usually, if you want to visit that, you have to schedule long ahead. But because the organizer are from CERN, so I get to see that. So that really reconfirmed that maybe doing this kind of games, community education mm-hmm. could be a viable career option. And so I reached out to my mentor from the Qiskit camp and see whether they have a job, and turns out they can hire me. And then I take a strong decision. I quit my PhD and I started this job in IBM Quantum. So that's really a long story and a lot of ups and downs.
That's a really exciting journey. You've done so many different things. So starting off in materials science, more or less, and then going into experimental physics, and then into all this community stuff and the quantum computing. You've managed to cover a lot of very different topics over those years. Mm-hmm. It's really interesting to hear that. I guess what made the difference for you was people, was talking to people, was meeting with people. It wasn't just doing the kind of the fundamental dry physics or the publications, but it was about being inspired by people and then having the opportunity to then inspire people in turn and have them react to the things that you were creating and be excited about the things you were creating. It's an interesting lesson in there that physics is and always has been done by people, and not necessarily isn't equations in the books, but it's the people doing the science, doing the work.
Mm-hmm, that's right.
So, given that you come from an experimental background, you don't work on experiments at the moment, but are there any skills that you've learned from your experimental career that you've managed to bring with you into your community work?
Mm-hmm. Absolutely. I learned a lot about vacuum chamber lifting. Just joking. I think the most important thing that I learned is not really the things that I do so much as an experimentalist, like those things that you think like fabrication and things, because I'm no longer a researcher and I don't go to research lab. I think the most important skill I learned is Python. And so around the time that I was doing PhD, I think Python 2 is ending the support. So we need to migrate our measurement software to use Python 3. Mm-hmm. Of course, actually no one asked me to do that, but I was interested. So I refactored all the measurement software that was written, like it's just some custom software in my research lab. And I refactored the software to use Python 3. And that really trained me how to do software development. Mm-hmm. And I also put the source code on GitHub. And then I also learned how to work on using GitHub and how to do the releasing software packages. And that turns out to be the most useful skill that I still use day to day, every day now. And beyond that, I think would be the ability to grasp some key information by reading a research paper, because that is still required in my day-to-day job, that maybe there's some new research funding, new thing that just to keep ourselves up to date with the latest developments. Mm-hmm. And if I don't have the research PhD background, maybe it would be harder to read complicated research paper and to understand what it means. Or at least I think I gained the confidence that I am able to read, because I've seen colleagues that they just feel that they are unable to read this paper because they are not used to. And then I think also the ability to make technical presentation, presenting complicated concept using some simple simple way to deliver to a wide audience.
I think that's a really nice illustration there of the different skills you can acquire during a PhD without necessarily being aware of it. I mean, a lot of people get to the end of a PhD and you say, okay, well, you know, what have you learned? And they'll say, well, I'm an expert on the Hubbard model. I'm an expert on
Yes.
topological anions or something. You know, they'll have some very, very specific thing, but actually along the way, as you say, you've had to learn all these skills. You've had to learn how to learn from papers. You've had to learn how to present, how to communicate, all these little technical skills like coding some small thing or learning GitHub, the things that you learn in order to do your job, but actually turn out to be very, very valuable in the long run.
Yeah, I think it's definitely something that if I would suggest to like the graduate schools or like postgraduate education, like a university, I think that would be to emphasize a bit more on these kind of skills that are more transferable, because PhD research topics are really specialized, because those topical knowledge that you learn is really not useful beyond if you are not a researcher anymore. So I think if the postgraduate research, the education system can really value that the part that's just beyond research, but you are training the student, not just preparing them to be a researcher, but maybe for other career options.
Yeah, definitely. I think that's a really good point. And particularly with the rise of a lot of quantum startups and companies now, there are more options than ever before for people, rather than following a research path, which, as you mentioned, can be extremely difficult. Now there are a lot of other options that seem to value different skill sets in a lot of different ways, and that's really, really nice to see. So if you weren't doing your current job, what do you think you might be doing instead?
Yeah, so if I didn't go to the Qiskit camp and make Q-Pong, I think I would be probably still in my lab and then doing postdoc, because I think my research probably was not going so well. So maybe you take extra time that I would be trying to really complete the experiments. So I'll probably still be a postdoc in my lab. And then the alternative path is that I got into game development after making Q-Pong. So I actually tried to become a game developer, not necessarily for quantum games, but like really for game development. So I tried to join a few game jams. And then I just quickly realized I'm a terrible game developer and game designer. So I feel like either route would be a tough job. Also, I learned is that game developer job is really tough. It's like you work over hours. You have a lot of crunching. You have also the projects last really long. So I'm pretty happy that I'm ending up doing a quantum developer advocate rather than these two alternative paths, because either path would be a much tougher job.
Yeah, it sounds like you're in the right place. So you mentioned a couple of times in there Qiskit. So for anyone listening, that's spelled Qiskit. Can you tell us a bit more about what Qiskit is and what your work involves with Qiskit?
So Qiskit is an open source software development kit that is used to program quantum computers. And what I do as a quantum developer advocate is to teach people how to use Qiskit, and then using Qiskit to program quantum program to run on actual quantum computers. And the things that we do include like running events like workshops, hackathons, or large-scale online things like the IBM Quantum Challenges, Qiskit Global Summer Schools, these kind of things. More recently, I have been working on improving the Qiskit documentation. I also run a program, I used to run a program called Qiskit Advocate Program, and that is actually a program that is supporting the most active member of the Qiskit community to do kind of like a mentorship program, or to invite them to events that we organize, to give them more opportunities to train and to take quantum computing as a viable career option.
So the Qiskit framework then, this is also, if I remember right, this is in Python, which you've already mentioned, right? So it's a Python-based software that you can use to develop or to run simulations on real quantum computers and kind of mock quantum computers running on classical hardware as well, right? So you can test your system, test your code on classical computers, but then deploy the same code on real quantum devices. Is that correct?
Yes. So Qiskit has actually many modules, and also there's an ecosystem around it. So core of Qiskit is called Qiskit Terra, and it contains the functionality of how to make a quantum program in the level of gates or even pulses in a lower level. And you can also have, of course, a lot of things surrounding things to support how we compose the circuit and running it into actual quantum hardware. For example, a transpiler, which is actually converting the ideal quantum circuit to run on an actual targeting hardware, because depending on your hardware, like superconducting qubits or trap ions, the available gates are different. But when you actually write a quantum program, you just write the ideal one that you think you are, and then the Qiskit transpiler take care of this translation. So a lot of job of Qiskit Terra is really translating these gates and actually to run on an actual quantum system. And then around the Qiskit Terra, there's a lot of things in the Qiskit ecosystem. There are things that made by IBM, for example, Qiskit Air, which is a high-performance simulator that allows you to simulate quantum programs so that you can do like debugging or developing your program before you actually send a job to IBM Quantum systems. Or there's also other things like Qiskit Nature that is have a lot of surrounding software library to help you to how to encode a like chemistry problem or physics problem into something that can be solved by quantum computers. There's also a third-party software in the ecosystem. We have a lot of, for example, providers. What we call providers are the hardware provider, the plug-in interface to other third-party quantum systems like trap ions. We have for IonQ, we have for Continuum, we have for even the multi-providers like Azure Quantum or Amazon Bracket.
Wow, okay, so it's really very versatile what you can do with this. I actually had no idea that Qiskit could translate the quantum circuit for specific hardware devices. I didn't know this. I played with Qiskit. I think anyone who's worked in quantum computing has probably at some point experimented a little bit with learning how it works, but I didn't realize that it had that depth of functionality. That's really interesting to hear. So you've been very involved with the Qiskit Advocates program. Can you tell us a little bit more about what that is?
Yeah, sure. So Qiskit Advocate program is a program to support the most active members in the Qiskit community. And in the program involves that you can join a Qiskit Advocate mentorship program. In the mentorship program, we have people from IBM Quantum that are expert in research or in the software development, and also non-IBM Quantum. Maybe they are Qiskit Advocate or external researcher. And these are the mentors that can get paired with Qiskit Advocate mentees, and they work on some project for 3 to 6 months time, and then they will work on this specific topic. And within that, you also have a career advice component that a mentor can give advice to the mentees, what it is to be working in the quantum computing industry. And so it really helps people to get started into, like, to have a taste of the industry by the working aspect and also getting advice. And also it helps them to have this experience that may be helping them to applying for internship or applying a full-time job. So I'm really excited that this mentorship program is helping a lot of people. And there's also things beyond the mentorship program, such as when we organize events or our partner clients that have some events, we can invite the Qiskit Advocate to support the events, giving talks, like hackathons, they can become mentors. So this kind of things really just like helping them to build their resume to be able to like really start other kind of more serious kind of career things. And also in our IBM Quantum internship, being an advocate is an advantage, so they can also apply for IBM Quantum internship a bit easier than other people. At least you get highlighted, and maybe you can go to the interview stage and things like that. So, and I'm also excited that since we launched the program in 2019, we have seen a lot of people that becoming Qiskit Advocate and then later really working in the quantum industry. I can't claim that they joined the quantum industry is because of joining Qiskit Advocate, but I would say that I think it probably helped them quite a lot because they give them exposure, give them opportunity to do various things, and then they work in IBM Quantum, work in other companies, and I'm just really happy that we see more and more people get to join because traditionally more people are just training in research or computer science background to do this, but we really need a lot more people to work in this industry because it's growing so fast. And waiting for people to be able to just start a program in undergraduate and then master and PhD is a bit too late. So we need to enable people that to be able to join even they don't have the specialized training in quantum computing. So I think that programs really plays nicely to be able to train the workforce that we need to really grow the quantum computing industry.
Yeah, definitely. It sounds like a fantastic opportunity for anyone wanting to get involved with quantum computing. So then what does a day in your life look like? It seems like you're involved in a lot of very different projects, all with the same goal of, I guess, educating and empowering people. But what does a typical day at work look like for you?
It's really hard to say what's a typical day. Like you say, that I'm involved in many different projects. And also there's many, I have a lot of colleagues also have the same job title as me, quantum developer advocate, and they all do very different jobs. So I can say what have been involved and how what a day in my life could look like is, as I mentioned before, that I was involved in like IBM Quantum challenges, or sometimes conducting a workshop, giving talks, hosting hackathons. More recently, I have been involved in Qiskit documentations, and also I have been working with a front-end developer to put a new page on Qiskit.org website, qiskit.org/providers, which is highlighting the various different hardware system, software system, or cloud simulator that Qiskit can connect to. And so really is a huge variety of different jobs. So my job involved could be, when I'm working on more Qiskit documentation, would be I go to GitHub, and then I will see whether there's other like issues or the user have reported maybe there's a bug in the documentation, maybe there's like errors or maybe formatting and things, and then we're trying to see how to prioritize those and try to fix. And we're also working on improving the Qiskit documentation as a whole in terms of the infrastructure, how to build them more efficiently so that, because Qiskit is open source software, we have a lot of external contributor contributing to it. We also improving the Qiskit documentation building so that external contributor can build the documentation on the local computer, and then they can, if they see an error, they can fix it, and then they make a pull request, and then contributing to the Qiskit documentation project. So that is about Qiskit documentation. On the website front, so I will work with front-end developers that is also inside IBM Quantum team. And then what my job is to gather all the existing Qiskit providers around the internet, trying to dig in, and also in the website itself, we have information about the provider and also code examples. So what I did was I wrote some script to trying to automatize this thing, because we actually have like 30 different providers, and we want to write a few, like 3 different code examples, like simple code example, like running a bell circuit, running a VQE, transpiling circuit. So handwriting individual one would be really time consuming. 3 times 30 is already 90. So what I wrote was trying to make it a bit more scalable, that I can just say I want to write these 3 algorithms and then these 30 providers, and each of them have some specific information, but I can write a script to synthesize the final code output that they will all work, but I don't need to write them individually. So that involves some kind of programming, but also about like researching different type of things, and also how to test the code. So it's really involving a little of this. And also, of course, I need to communicate with the front-end developers about what we want to do, what we want to achieve, and how we can achieve them, giving the limitation, maybe at the front end, certain framework they use, certain guideline they have to follow. So it really involves many different things.
It's a really interesting balance there of technical skill and communication skill, because I guess you're working with the community in terms of Qiskit, the documentation, and bug reports and things like this. You're talking a lot with users, I guess, but then also you're talking with front-end web developers and partner companies working with you. So yeah, I guess you're communicating with a lot of people in very, very different roles, all of who probably want slightly different things from Qiskit and from you, and who are probably using slightly different technical terms. So That must be a really challenging thing to stay on top of.
Yeah, I think definitely that is a big challenge, and also probably I think what we should really focus on doing something like deep technical problem like your research, and then you have to talk to people from different disciplines, and that actually allows you to have this training to be able to do this, because actually it's really a essential part of many jobs, even for not quantum, like any other technical job, because very often you have to explain something that very technical that is only knowledge people within very small circle knows, to explain another things. Like I talk to front-end developer, I need to learn that language. I need to know what kind of tool they use, what kind of terms they use. Like you could describe a thing for like one paragraph, but actually if you just know exactly what term they use, they just get it immediately.
Yeah, I mean, I feel like that's one of the big challenges facing the sort of quantum technology community right now, is that it involves people from so many different backgrounds, from physics, from a little bit from materials science and chemistry, from computer science, people with mathematical backgrounds, and sometimes we do end up in these situations where we use the same word to mean completely different things. And I find that leads to some very confusing situations. Getting everyone on the same page, just using the same language, or just understanding what the other party means. It feels like that must be a really challenging thing to do on a daily basis, to keep mentally adjusting and thinking, okay, this person is from this background, this is the correct way to talk to them so that they'll understand quickly and efficiently what I'm trying to say.
Yeah, related to that is, I mentioned that Qiskit is an open source project, and then so it's a quantum software. So like you say that people working in the field have different background, or science background or computer science background. So the people that contribute to Qiskit also have various background. People that have computer science background, they are more used to like how to use Git, GitHub, or the coding Python. But they are more scared of the quantum aspect. Like they think that they don't understand what's going on in Qiskit, the software. Well, on the other hand, people that with more science training, they might be researchers. They might actually use Qiskit for something very advanced, and then they see some problem and they want to improve. But because they are not so used to writing code, or they don't know how to use GitHub, so for them to contribute to Qiskit is also a lot hurdle to overcome. So one of the things in my team, the Qiskit developer advocacy team, do is also to facilitate external contributors to contribute, because people really have various background, various expert. For us, we need to do a lot of hand-holding to make the people from more research background to be able to just do some basic thing, like when you make a pull request, you should add a test to test the thing that you change, or write a description to describe what you change. Like something really basic, maybe for computers, science background students, it's not obvious at all for research background. And vice versa, that for someone to motivate someone from computer science background to start contributing, you could tell them that there's actually a lot of non-quantum aspect in Qiskit that you can contribute, and you can get started there. And even for very quantum concept software inside, it's not that difficult to understand if you just overcome this first barrier of like scale. Like you just think that you won't be able to understand because you don't have the training.
So you've been very involved in a lot of different aspects of community work, including things like Qiskit Advocates Program, but also Quantum Challenges. Can you tell us a little bit about the different types of projects that you've been involved with and why they're so important to you?
So I can first talk about IBM Quantum Challenges, because really dear to my heart in many aspects. First is that it is a really big scale online event that really allows many people to get started in quantum. In fact, many people in our Qiskit community get started by doing a quantum challenge first, because it's a very intense thing, just like a week or two, that allows you to really focus and learn a lot of things in a short time. And then after they finish the challenge, they feel like, okay, they already get started, they can start exploring different things. So this is really important event for us in IBM Quantum, and also for the community. I think it really help people get started. And for me personally, also I have been involved in many quantum challenges, including leading one of the quantum challenge in May 2021. And that really just trained me as a person for the leadership, like how to lead a team to make something happen, because it involves many different people. like 40 people. Some people are directly managing, some people I have to work with, and that really scaled across really different teams in the IBM Quantum, down from like deployment, because in that time it was the first time we allowed IBM Quantum Challenge participants to have exclusive access to a real IBM Quantum systems. We allowed people to use a 7-qubit system and also enable them to have the pulse access. That is lower level access than the normal gates that you find. You can define a waveform and then controlling and sending waveform to control the qubits. That is not normally enabled for open access plan, but that was one of the things that we designed in one of the challenge problem. And so they have deployment team. I need to talk to people on the software development team because some of the capability may not be stable. There was bug that we discovered while we're developing the challenge content, and we need to fix it before the challenge. There's also, of course, marketing. We have people actually running the program within our community team. I also need to work with external people, like we have the Qiskit advocate who help us to run the challenge. They are mentors, they help the participants. So I need to talk to them, train them. And so this really involves a lot of things, and also making something happen in a very short amount of time and have a tough deadline, because you say you're going to launch in a certain date. You have committed to a very public date, and there's going to be thousands of people running it for just 1 week and two. It's a big challenge, and I just feel that I learn a lot by really leading a quantum challenge, and so for me it's really an important thing. It's just trained me as a person.
It's interesting that you've benefited, I guess, from taking part in these sort of like hackathon challenge events yourself, and that has opened up a lot of opportunities for you. And then now you've got on to be in a position where you can lead them, you can deliver them, you can give those same opportunities to new people, and then who knows what they'll go on and do with it. That's really exciting.
Yeah, that's exactly. I feel like just the fact that I come from a community, like I was joined a Qiskit camp, and I was also one of the first batch of Qiskit advocates. And after entering IBM Quantum, I actually run the Qiskit advocate program short afterwards. So it's really interesting that how I become just like from the person that is actually participating to someone that is actually helping people participate. And I do feel really happy about doing these things, because I can see that other people like that was maybe frustrated to trying to get into quantum computing industry. Mm-hmm. And by doing this kind of events or some initiative can help these people find different kind of path beyond just researcher. Because I think from the way I talked to, also the way I was thinking, I thought the only way to contribute to quantum computing industry is to become researcher, either theoretical researcher, developing algorithms, or hardware researcher, making better hardware. But actually, just like any industry, you have people doing all kinds of jobs. You have people building the website. You have people that doing like us community building. We have educators. We have people doing marketing. We have people doing HR. Mm-hmm. Like those things that you usually don't consider as a quantum job, but actually they make significant contribution to the industry. And those things should be considered as a viable option if of course they align with your interests. But that's one thing that I often remind people that I interact with, that they feel they cannot find a job, because really finding a decent PhD and become a researcher and then at the end working in research is just really, really, really difficult. And there's just a tiny percentage of people can really make it. And it's not about whether you are smart or not. Sometimes just because you are not in your educational environment doesn't enable you to have that. Maybe you're from a country that doesn't have those kind of opportunities.
Mm-hmm. Yeah, I think that's a really important point, that there are so many, a very diverse range of different roles available now in the quantum ecosystem, that it's not just the case that you have to be a researcher, but there are so many other ways to contribute. That actually leads on quite nicely to one question that I ask all guests on this podcast, which is to say that physics has historically been a field dominated mostly by white cisgender men for a very, very long time. And there's still quite a long way to go before we reach any kind of level playing field. In your experience, having worked both in academia and in industry, and having worked in several different countries, Have you seen attitudes towards diversity changing over the years or between the different countries or industries that you've worked in? And are things getting any better? Are things changing at all?
Mm-hmm. I definitely think this is an important topic, and I really like that you include this question in every episode of your podcast. And I also think that the quantum industry is still young, and we have a unique chance to make it right, that we care about this problem and then start taking action, because it takes time to actually make it right. So I can say from IBM Quantum that I'm proud to say that I think we are doing a pretty good job, and we have initiatives to help this both internally in IBM Quantum and also for the community. And then in terms of initiative, in our IBM Quantum, in our hiring pipelines, in internships and full-time hiring, we have initiative to increase the represented minorities in the hiring. And also for externally, we have the IBM HBCU, historically Black Colleges and University Center. Mm-hmm. That's really giving opportunity for Black students to do research and to have a career in the quantum computing industry. We also partner with Qubit by Qubit School, and the Qubit by Qubit School is an online course to teach quantum computing for many people, I think more than 10,000 people. And that school has a strong focus of helping underrepresented minorities. I think more than 40% of the students are the minorities. And then we also do a lot of events focusing on women in tech. So we have a Women in Quantum talk series, and we also do recruitments in women-focused events like Grace Hopper Conference.
That's really great to hear. And I think what you said at the beginning there was a really interesting point, that because this is such a young field, now is the time to take the lessons learned from maybe the older fields where these biases and imbalances are so built in that they're quite hard to shift. And now is the time, when this new field is starting, take those lessons, apply them, do it right from the beginning, and then hopefully it will remain right in the future if we get it right now. That's a really interesting point.
Definitely.
All right, one final question to wrap up then. If you could go back in time and give yourself just one piece of advice, what would it be?
I think this sounds a bit cheesy and maybe it's not new. I would say that follow your heart. Maybe you can hear from my journey. I feel a lot of things that I do, like the coupon or maybe reading the books, these sort of things are pretty random. And I decided to do them not because I think it's going to be good for a career, but at the end it actually make a significant impact on my life. And so I think of course you should have some target in your life and try to do that with reasons, but also maybe from time to time do some side project that just spark your interest. And maybe those things actually going to really make an influence. And even if they don't, at least you have fun with it. Right.
Perfect. I think that is a fantastic place to wrap this up. So if our audience would like to learn a little bit more about you, is there anywhere they can find you on the internet, on social media, anything like that?
Yeah, definitely. I'm pretty active on Twitter and LinkedIn. You should be able to find me. You can search for my name and you should be able to find me, or on GitHub. Or if you join the Qiskit Slack workspace, you should also be able to find me.
Perfect. Well, we'll leave some links to those on our own website, insideQuantum.org. Thank you very much, Junye Huang, for your time today.
Thank you very much.
Thank you also to the Unitary Fund for supporting this podcast. If you've enjoyed today's episode, please consider liking, sharing, and subscribing wherever you like to listen to your podcasts. It really helps us to get our guest stories out to as wide an audience as possible. I hope you'll join us again for our next episode. And until then, this has been Inside Quantum. I've been Dr. Stephen Thompson, and thank you very much for listening. Goodbye.